During the June holiday, me and my friends did a project about paper chromatography with M&Ms. Our group leader is Angel, and the members include me, Natalie, and Ghazali. What was this project about? This project was about paper chromatography. Paper chromatography is a method to separate or dissolve colored chemicals or substances. In this case, we needed to separate the colored clothing from the M&M candy to find out how many different dyes were found in the different colored M&M candy. The theory behind this includes two phases that will occur, which are the mobile phase and stationary phase while carrying out paper chromatography. The stationary phase includes a filter paper which will be used to support the dissolved fluid of the M&M color coding. The mobile phase includes dissolving the M&M color coding with a solvent. In this case, we used water to act as a solvent. The materials needed were one packet of M&Ms, one bottle of water, a handphone camera to film the process, stationaries which include a pencil and a ruler, and chromatography paper. The procedure throughout this experiment was, firstly, a line was drawn horizontally across the chromatography paper that was placed vertically using a pencil and a ruler. Next, the line was drawn at about 1/4 away from the bottom of the chromatography paper. Secondly, an M&M candy was placed slightly above the line drawn. After that, a few drops of water was added to the M&M to dissolve the color coding of it. Lastly, the following steps were repeated 2 more times with the M&M of different colors. So, in the end, we ended up with these results. We started off with 1 drop of water, nothing happened, hence we added about 3 more drops of water to the M&Ms, and slowly we observed that the color coding of the M&M started dissolving onto the chromatography paper. After that, we have observed that the color coding that was dissolving for the blue and yellow M&Ms on the chromatography paper started to have different shades of the color of its color coding. However, for the green M&M, not only did we observe the green dye, we also observed that it had another 2 dyes which were yellow and blue. About 7 to 8 minutes, we observed that the blue and yellow dissolved colored coding had a lighter shade of the same color than the bottom of the chromatography paper, which had a darker shade. We also observed that the green M&M candy had light shades of both yellow and blue near the top, while having green dye nearing the bottom of the chromatography paper. We tested a total of 3 M&Ms, which are the blue M&M, the green M&M, and the yellow M&M. We all did videos to record the dissolving of the color coding. So in the end, we analyzed the data collected by observing the different shade of color that was left behind by dissolving the color coding of the M&M's candy. What we found out was that there were 3 dyes in total observed in the green M&M, which was green, yellow, and blue. The reason why there were yellow and blue dye present in the green M&M was because the mixture of the 2 dyes would create the color green, and green is coincidentally a secondary color. Hence, there were yellow and blue dye observed as it was needed to create the green color coding of the M&M. We also found out that the yellow and blue M&Ms didn't have more than 1 dye in its color coding, as yellow and blue were primary colors and did not require a mixture of color to form their colors. So in conclusion, we can conclude that the color coding of some M&Ms do not exist as a single compound, while other M&Ms exist as a single compound. M&Ms with a color coding of secondary colors such as green will have 2 dyes, blue and yellow, to create the secondary color. Therefore, M&Ms with a color coding of secondary colors do not exist as a single compound. M&Ms with a color coding of primary colors, however, exist as a single compound and does not require a mixture of dyes to create the desired color. Along the way, we observed something unexpected, which was there were random white spots in between the dyes. I think if we ever follow up the experiment in the future, we can improve the experiment by using a syringe to measure the amount of water used to dissolve the M&M. It is to be more precise of how much water is going to be used to dissolve the color coding of the M&M. And these are the references we made while making the PowerPoint slide and researching.